this is Flux of Fluxwithit.com, and we are here at the Mordax booth. I almost wanted to say Mordax Data because that's what you guys are known for.
We got a couple of those.
We got some new stuff here.
We have something new today.
And yeah, I'm super excited about this. Now, I'm going to come over here and zoom in a bit. And what I want people to see is that this sucker, it looks like, on the surface, sampling.
Oh, yeah.
Sampling, sample playback. All right.
Yeah,
with a brilliant looking screen on it. And another extremely important factor on here that a lot of people aren't aware of, the waveform color currently is green. And that should make everyone happy.
Oh yeah, we got your colors, Flux.
All right.
Yeah, so this is the GXN. This is our new product we're working on. And it is a granular synthesis system. It's, it does sample recording and playback, but it does granular synthesis. And so you can create little chunks of sound and then precisely control how those chunks are overlapped. You can control the grain size, you can control the grain frequency, the density, and it is pretty crazy. And so right now we got a sample of a classic sample, an almond break coming on, and we have it going through a quadra envelope, so it's being gated, and so we can move the start position around, So yeah, you can get some different hits, but then so you can start doing some granular stuff. I'm going to open up the envelope so it's just a continuous stream, grain stream. Now you can really hear the granular effect of our window. And let's turn it up a little bit more. Let's turn on some randomization here on the start position. So yeah, it's pretty crazy. Okay. All right, so let's do another sample here.
Can you tell me about the inputs on here first?
So we got stereo inputs, a trigger, record, volts per octave pitch, clock. We got 6 assignable CVs and 2 assignable outs, and then left and right outs. We haven't fully cemented the input-output system though, I'll say. But we don't have the pitch interpolator show ready yet. But so subject to change, but this is what we're looking at for your I/O.
Can you explain to me a little bit about what the button layout is here?
The button layout, yeah. So that's it's going to be soft buttons for the UI. We just have the granular engine built, and this is like a prototyping UI. So this isn't exactly how it's going to look.
So we're very early right now.
Yeah, we're pretty early. We've just been spending months on hardware and the grain code. But yeah, so this is the waveform, file name, things like that. We'll have that on here, but the actual controls will look a little bit different. But yeah, so it's just to give you an idea and start the conversation. Do people want granular synthesis? I do. Well, that's how you do some pretty crazy stuff.
Can you tell me a little bit about what the whole idea of this module is? Is it designed to be primarily granular? Is it for live sampling? Is it drum triggering? What sort of latency are we getting? I want to know all the details.
So the idea behind this is, We've been making electronic music for a long time, and when we first started, I really liked Reactor, and I made a grain sampler in Reactor. This is like 2001, 2002, and that was one of our main instruments.
Hold on.
What's that?
Did you share that in the user library?
I didn't.
You didn't?
No.
That's
kept it for
selfish.
myself. Very
Okay.
selfish. In retrospect, I was being really selfish, but no, this grain sample that I made in there was became like one of our primary instruments when we were playing live and jamming and stuff, and it was something that I missed when I really don't use the computer for like making sounds and music. I use it for recording primarily. I really like hardware, and I was like, I really wish I had something like that again, because the granular techniques are very interesting. It's very unique, and it seems like for the most part, it's just like software is how you can really access that. So we wanted to like make a grain engine that the whole enchilada, it does very accurate positioning and sample control, and to get the kind of sounds that we had before. So I missed them, and so in doing that, you create a sampler that's capable of doing all the things that a normal sampler can do, auto recording and playback, and then it does a little bit more. And so we've been talking about different ideas for the design as far as having modes. So in one aspect is like, so there's the granular playback engine, but then you could have a mode that treated the grains like individual one-shot samples and have manual granular triggering. Because the grain sampler itself is already a polyphonic sample playback engine. The grains are being generated and stacked and overlaid on each other, and so there's this, you already have polyphony in your audio stream, quite a bit of it. And so, we've been thinking about some additional modes that you could use this thing for. Trigger sampling, polyphonic drum style, as well as like transient wavetable oscillator kind of thing. Building a wavetable out of different pieces of a waveform. There's a few ideas we have, but we'll have to stay tuned for probably Super Booth is the next time I'll be showing this.
Are you anticipating being able to set like sample length and then being able to track volt per octave so that you get accurate pitching? And
yes.
Yeah. Oh, that's fantastic.
Yeah, I'd like to have it be pitch per grain. Because you could interpolate the whole stream, but I think it'd be more interesting if each grain that's generated has its pitch assigned to it at its birth.
So I know that this is very early, so a lot of the functionality isn't quite in there yet, right?
Yeah. We have the microcontroller, the architecture of the system, the communication libraries, and the primary granular generation engine.
So I'm going to ask some questions.
The UI is what we're working on right now.
I'll ask some questions about things that maybe aren't in there yet, or maybe that you've thought of.
Yeah.
But so for instance, you had an AMM break up here.
Uh-huh.
Are you considering saving slice points?
Oh yeah.
Yeah. So that you'll be able to re-trigger and jump between slice points and variations.
You'll be able to scan based off of a voltage level, which would then correspond to a note. So you could have a sequencer that plays notes out of with CV, and then you could assign those specific CV voltages or just note name to your sample start point, and then so I was saying like having it be like a polyphonic drum trigger.
Okay, so in regards to, obviously it's early, so it's not optimized, but are you shooting for a latency number? Do you have that in mind at all?
Right now the buffer size is the hard line for latency is under 1 millisecond.
Oh, excellent.
Right now I think it's like 0.3 bar.
Oh, okay.
But
okay.
like
so
you said, it's not optimized,
Yeah.
So like we'll see how much space we got. Like I said, potentially these outputs, I'd like, because there's going to be internal modulators beyond the one that we have right now, which is the grain envelope. I don't have the controls up for it, but there's each grain has basically an AD envelope applied to it that you control the A and D's point. But I'd like to also have sort of flexible modulators that could basically an LFO envelope internal to the grain sampler, and it'd be cool that you could assign those just like you would the CV control from the front jacks, these internal CVs, but then you could send them out. Because I got 12-bit 2-channel DAC that I'm not using that's just part of the microcontroller. I'm like, well, I could use that, and I could send out the internal modulators as well, which would allow you to, like, say, control a filter from the grain samplers modulators, and kind of like bring in that to the system, synchronicity-wise.
This is pretty cool, man. So I'm adjusting the loop length right now, the size of the grain essentially. Very cool. Now, let me bring this down here so that we get, there we go, back to silent.
Yeah.
So will you be able to do things like essentially variations of everything through modulation? Are you going to have a inbuilt modulation matrix?
Yeah.
Well,
yeah,
super close.
That's the idea. Whoa.
Extreme close-up.
Yeah, that's the idea, that you'd be able to route the kind of like on the data. It's like the data here has the 4 front jacks, right? And then this is the oscillator program, and so you can assign, like, here's this pop up the CV, and then the CV window gives you the option to assign the CV control from, any of the 4 front jacks can control the frequency or the amplitude of either the 2 channels. So you could effectively say, I want jack number 1 to control frequency and amplitude and frequency and amplitude of channel 2. You could have them all coming from 1, or you could split them out. The same thing is for the grain.
Is there any sort of timeline on this at all yet?
Yeah, we're hoping to have a production prototype for Super Booth in May, and then go into production this summer. So we're thinking, summer or fall for them hitting the retail stores.
Yeah, it looks great. And what I'm really interested in is the fact that, it's based around the idea of granular, but you also have other modes of triggering. And
there's a lot you can do as soon as you have that kind of control.
I can think of a lot
of,
like, myself over at Fluxwithit, and then, Corey over at B-Boy Tech Report. We use a lot of these modules for hip-hop, and so we're kind of tied to samplers deeply, and this kind of thing
having the clock input where you can analyze your tempo and then synchronize grain size and transitions, I think it's going to be killer for rhythms.
Excellent. And right now you guys have the Mordax. These are shipping now, right?
Oh yeah, we got these in stores. There's starting to get low on stock. We have another run coming up here March, April.
Yeah.
But there's a few stores that still have stock, and so we have a couple on our site too.